Hello everyone, welcome to Coders Camp, and today we are the 14th day of April LeetCode challenge, and the problem we are going to cover is partition list. So the input given here is a head of a linked list and an integer variable x, where x point at the partition of the linked list. We have to arrange the elements in such a way that the nodes less than x come before the nodes greater than or equal to x, and we have to preserve the original relative order of the nodes in each of the two partitions. So let's understand this problem with an example. So here is our given input list and the partition element is 3. So now we have to arrange the list in such a way that the elements less than 3 in the second half of the list should be moved to the first half of the list. So if you observe in the second half of the list, that is after 3, the elements less than 3 are going to be 2 and 2. So now if we are shifting 2 to the first half of the list, then they come before 4. So now if you see, the list is going to become this, that is all two twos came before 4 and then 4 and then 3 and then finally 5, which is greater than 3. So here we have to maintain the relative order. So what is a relative order? If suppose the elements are going to be 2 and 1 here in the list, and if we are moving them to before the list, then it should come 2 and 1, because we should maintain the relative order. We should not swap the nodes or reorder the nodes. So now how are we going to approach this problem? So we are going to have two pointers or two dummy heads, small and large, where small is going to point at the elements which has to come before, that is first half of the list, and large pointer is going to point at the elements or nodes which are going to come in the second half of the list. And finally merge those two headers and return the result. So now let's have green color for small pointer. So I'm going to point at the elements which are less than 3 with green. So now starting from the first element, which is 1, which is going to be less than 3, so that comes under the small part. So we are going to point our small pointer at 1, and now our pointer small is going to be at the node 1. Moving to our next node, which has the value 4, which is greater than 3. So we are going to have a pointer purple, that is large, pointing at 4. So now it's time to move to the next element, which is 3. We are going to again have that element in large, because we are going to maintain large or equal in the large pointer. So now from 4 dot next point to 3. So moving on to the next node, which is 2, which is less than 3, so it comes under the small category. So we are going to point our 1 dot next, that is right now it is the small dot next to 2, and now small becomes 2, and same way large moves to 3. So now next element 5, which comes under the large category. So now our large pointer, that is large dot next, is gonna connect to 5, and large moves to 5. The next element is 2, and 2 comes under the small category. So we are going to point s to 2 now, that is current s dot next to 2. Then we are going to point s to 2. So now our iteration is completed, that we have iterated through all the nodes given in the list. So now our small pointer ends at the smallest element and large pointer ends at the large element. So now wherever the large pointer is, that is going to be the last element of the list. So we found the last element of the list. So we are going to connect null with that. So the next to large is going to be null, because that is the end of the list. So now our small element is at 2. We are going to connect our small with large dot head. So we're going to have a dummy pointer at large where it has started. So we are going to connect small to large, so that now the list is sorted in such a way that all small elements comes in the front and all large elements go to the back. So hope you're understanding the solution. So this is going to happen in one pass, that is it is going to iterate through our given list only once. So this is going to run in big O of n time complexity and constant space. So let's go to the code now. So first I'm going to have two dummy pointers, head 1 and head 2. and I'm gonna declare my small and large to head 1 and head 2. So to iterate the given list, I'm gonna have a pointer current, which is gonna iterate through our given list. So now I'm gonna iterate till my current node reaches the end of the list. Then I'm gonna check every value or every node's value in the list, whether it is less than X or not. So if it is less than X, then we are going to point that to the small category. So small dot next will point at the current element, and now small moves to the current element. If it is not less than X, then we are going to point the large pointer there. So yes, so for every iteration, current is going to move to the next node so that it will iterate through the list completely. So yes, everything is done. So now we are going to point large dot next to null, since it is the end of the node or end of the list, and small dot next is equal to head 2 dot next, where we have assigned head 2 to large. So this is actually going to point at the first node in the large list. And finally return head 1 dot list, that is small, where the small is starting. As the first node of small is going to be -1, from the next node it is going to be the actual output we need. So let's submit now. Yes, the solution is accepted and it runs in 0 milliseconds. So thanks for watching the video. If you like the video, hit like and subscribe. Thank you.